Hello everyone, good morning or good afternoon, depending on where you are. Welcome to our webinar, What's New in IP 2021. So today we're going to show you everything that's been added to the latest version of IP 2021. So we've got multiple presenters today. Rather than just go through a whole list of features, we've actually broken it into different disciplines. So we're going to have an introduction from our VP Subsurface, Derek Crombie. Our product champion, Paul Spooner, will then cover most of the sort of general Petrophysics upgrades. I will then give you an update on new things within the cased hole area of IP. We've got lots of new geomechanics features and upgrades that Frans Mulders is going to tell us about. And last but not least, we've got Tegwyn, who is going to be giving us an update on image analysis upgrades and the new Textural Facies module. Regarding questions, so within the GoToWebinar panel, you should see a kind of little drop down area that says questions. If you just write in any questions and that during the presentations, we won't stop for questions in between, but we'll save them up for the end, so we will try to answer all your questions. So, and then we'll cover them at the end, the Q&A at the end. Quite a lot to cover in this, so it's very much just an overview of everything that's there. If there is something that you're very interested in, please feel free to get in touch with us and we can arrange a more detailed discussion on an individual item. Okay, with that, I will hand over to Derek.
Okay, thank you. It's Derek here. I'm just going to give a brief introduction to IP 2021. I will just share my screen. And I will stop sharing my video. IP 2021 is based on our customer feedback, and some of the things we worked on in the last year was, one, to modernize the user interface. This was quite a big undertaking. I've personally been using IP for 24 years, and the main user interface hasn't really changed dramatically in those years, so it was time to give it a more modern look and feel. Add some more ways of visualizing the data, which Paul will show. Have a deeper insight to the existing data. Come up with other ways of looking for erroneous sections of log data before you bring them into other workflows. Adding to our well integrity management solutions with casing inspection module, and a whole host of enhancements across many of the workflows within IP. So the new user interface, it's a new modern refresh. It uses a design technology or a design concept called material design. It's cloud ready. It uses cloud native technology. The UI change has been mainly associated with the main UI window. We've added some nice features like search features within the menu structure and so forth. So I'll just quickly give you a little overview of the new UI. This is what it looks like. We have moved the drop-down list basically to the right, and each one of these basically allow you to launch things. If you click away, it drops back to the browser, or if you lock the menu structure here, when you click away, it remains up, or you can always jump back to the browser like that. There is a search facility where you can type in here, say something like DLIS, and it'll show you all modules that are looking for D-lists. We've got some. We may take this further in the future, allow that search to go and search for different data and so forth, wells, curves, parameters, and so forth as well, based on customer feedback. You can customize these. We can put in different custom. You can add your own custom workflows here. And along the top, we have some quick buttons or quick icons. So there's the standard, moving wells up and down, selecting different wells, work sets. This is all about data saving. This section here is about the data management. So that's curve headers, curve set headers, and well header information. And then we have standard log plots, horizontal log plots, correlation plots, histograms, all the viewing, cross plots and so forth. All the viewing stuff is here, and then the standard deterministic petrophysics workflow with clay volume, porosity, water saturation, and cutoff summation, and then some management tools over here like help and dragging and dropping curves. All the same facilities you had there before with dragging and dropping curves still remains. Down the bottom here, it tells you what well you're currently focused on, the depth range and so forth, and you still have the tile buttons and so forth there. So that's the new UI. If you don't actually like it, or you don't want to spend too much time learning it, it's actually very intuitive. We haven't really made we haven't really moved things around significantly. The main thing is that the interpretation drop-down list had way too much stuff in there, so we've sort of split it out. The advanced ones, we've split it out. They had way too much in there to machine learning, cased hole, and geoengineering as well. But like I said, if you for some reason want to go back to the old UI, you do have the option under Tools, Option, Miscellaneous Options. You can go back to the classic user interface. But if you do that, we are asking people to give us feedback to let us know what they don't like about the new UI, because this is a work in progress. We are intending taking people's feedback and improving on it as it goes. If you don't like the color scheme, you can also go under options and pick a different UI, such as say a dark option there or anything like that as well. So there's a whole bunch of themes that you can also toggle between. And on that, I will pass you over to Paul.
Need to unmute myself. There we go. Hi. So I'm going to be talking through the Petrophysics upgrades. The first of these upgrades is a new module for LQC. And effectively, you can consider this as a precursor to the auto curve edit module that we released previously. That's a module that will repair bad data using a series of MLRs. But one of the inputs for every curve that you wish to repair is basically a good bad flag. And the workflow in there was based on the fact that you would open, say, a crossplot of density neutron, and you would create an area flag curve to say, this is the good data, and it would repair the bad data. This module will automatically create those flag curves for you. It's based on 10 sort of standard input log curves, standard triple combo curves, along with 2 bad hole flag curves, so a caliper and a delta row typically. And then for each of the curves that it's going to flag, it's got a set of parameters, which are user limits, and then there are extreme value limits, and they're interactive on the log plot. So for each curve, you've got interactive lines, in the track. So for example, with a gamma ray, I think the default user limit is 5 for the low end and 150 for the high end. If the data is inside that range, it will be flagged green. If it's outside that range, then it will be flagged as orange. The second set of limits are extreme values. So you might set that to say 0 for the low end and say 300 for the high end. So it will flag those purple if it's if it's beyond those limits. It will also automatically flag any nulls. So in this plot here, you can see that I don't have any shear or compressional sonic logs. It will flag any constant values, so repeating values will be flagged. That can indicate stick and pull, for example. And if the data is tripping the borehole flag, then you've got a choice that you can either just flag the data as borehole, as you can see here, so where the red flags have been tripped, or you can actually have it go ahead and null it. Any null data that goes into the auto edit will automatically repair the nulled intervals. And also the module does automatically write out these flag curves. So you can see on this cross plot, for example, that there's been some max min limits set on the density neutron, and I can see looking at that cross plot that I maybe need to lower the minimum limit on the density a little bit because I've got some light hydrocarbon in there that's being flagged as bad data that's not. So a little tweak on that limit will fix that. Because it's a conventional zonal parameter set, it can be run as a batch, multi-well. You can run it in 3D Petrophysics. So this interactive log plot could be a multi-well, correlation viewer, multi-well interpretation log plot. So you can quickly get to grips with, large data sets. If you're looking at a new asset and there's hundreds of wells in there, and you can quickly sort of, QC and understand, right, what log data have I got, basic log data, what's its state, good, bad, or otherwise, and, straight on into the auto curve edit. A new plot type is pie charts, and these can be plotted either as standalone pies or they can be mini plots on the log plot. And there's another new type of mini plot as well, which is a curve rows plot. So we've had rows plots as part of the image analysis workflow for a long time, but you can now put anything that's a curve that's got like orientation data in it. So typically maybe an isotropy from acoustic waveform data processing, or it might be your breakout analysis. So you can just you don't need an image log license to plot these things, and you can just pick up any curve data. So the main difference is it's picking up curves, not pick sets from the image analysis. On the pie chart, let me just go in and I will show you the pie charts live. So it's a mini plot. There's quite a lot of customizable features on these. Firstly, they can be a pie or a donut. It's a choice that you get to make in the UI. The colors for the segments, you can pick the colors, and they can be lith shadings as well, not just colors. You've got options about the labels. Do you want to label the sectors or not? And do you want the values or not? Do you want the depth range? And you've also got the options that come with mini plots, in that these two here are plotting the data currently being showed on the screen. So as I scroll the log, they automatically update to show you this is the Facies curve I've got in the last track. That's what's being plotted both as a donut and as a pie. Or you can plot them like this is every 20 meters. Or you can plot them by zone. So these are being plotted by the zone set. And the other new feature, or the new ability that we've added in here, is that mini plots can now be plotted in a track with other curves. Previously, they were just in their own track. And they can be offset from the middle, because previously they always plot centered in the middle of the track. So you can now push it off to the side and have it in a track with any other curve. And basically the data that these will plot is anything that is classified data. So something like a Facies curve with values 1, 2, 3, 4. But that could be fluid flags or reservoir flags. So here's like a net to gross pie, because you have the option to say treat 0 as data or treat null as data. So in this example, I've got the 0, so my reservoir flag is shading, and then the non-net is my zeros. So I'm getting a little net to gross for each zone. There's also a standalone version, which is under view. So there's pie chart, or if you've got the browser open, and you've saved any, it's also in here in pie charts. So you can just open from here. So there's a standalone one, which can be set up zonal, give you summaries, and it's all the settings are buried under the edit settings. Okay, what's next? Monte Carlo has had quite a lot of work done. There's 3 significant upgrades coming to Monte Carlo. The first of those is we've added a lot more of the workflows that you can now Monte Carlo. Very importantly, we've added in geomechanics. So all of the sort of zonal parameter sets aspects of geomechanics, you can now Monte Carlo those. And Frans will talk about a little bit more about that later. Sigma saturation, that's now been brought in. And also saturation versus height curves. So now that doesn't have a zonal parameter set, but you do have parameters for each hydrocarbon model. So you can pick up the parameters for each hydrocarbon model, and then you can put uncertainty on things like the free water level, the fluid densities, the IFT correction. So that's really quite powerful. If you put cutoff and summation into the workflow as well, you can then look at, say, how your hydrocarbon pore feet changes with the uncertainty in the free water level, for example. DTA can also be run in there as well now as part of a complete workflow. Monte Carlo now, the uncertainty parameters themselves can be zonal. I mean, within Monte Carlo, we run zonal parameter set workflows. So things like vclay, VSW, the parameters in there can be zoned. So you can have a different RW in different zones. But now you can put different uncertainties per zone on whichever parameters you want to put zonal values on. So you might want to just put different uncertainties on gamma ray, clean and clay, or RW, for example. And also the log inputs. You just check the option that you want it to be zonal, and then you can put per zone, you could either change the shift type, change the shift distribution, the low values, the high values. So that's really powerful, because previously if you wanted to capture the uncertainty in, say, RW, because in one zone you've got produced water, so you've got water chemistry and a very good understanding of RW. Maybe in another zone you don't have any produced water, but you did drill a water leg and you've got a good set of logs and a picket plot. In another zone, you might have only drilled the oil leg and you really don't know the water salinity. You are just using offset wells or assuming, well, this other structure over here, will make some assumptions. So you can now put different uncertainties in different zones. And previously you could do that, but you would have to make separate runs of Monte Carlo and then combine the results. Whereas now you can just do it all in one run. So it's a big time saver if you really want to get down and dirty with your zonations like that. You can also now save a specific case, a specific iteration. You might have run 2,000 iterations of Monte Carlo, and then we get the final results where you've got your P10, P50, P90, hydrocarbon pore feet, for example. You can now go in and say, no, but I want to see the specific case that gives me the 10th percentile of. You just have to select which result parameter and which zone, so all zones or one particular zone, and you can search the the P10 on average porosity or hydrocarbon pore feet or whatever. Say what percentile you want, and when you hit run, it basically looks at all the data, comes back and says, of your 2,000 runs, run number 123 was the 10th percentile for that case, for that parameter. You can then save the curves and save the parameter sets that were used in that particular run, that particular iteration of Monte Carlo. Because all the parameters that you've put uncertainty on, there was a specific number that was shifted to each parameter for that case, and likewise for the log curves. So by writing them out, literally as a curve set, and also as a folder in the well with a .set file, if you then open each of those elements of the interpretation workflow, like clay volume, load that parameter set, select those input curves, and then hit run and go through the entire workflow, you will get that exact case. So you can extract a specific case now from the workflow. There's upgrades in the NMR interpretation. Let me just flip into IP to quickly show you this as well. So if I change my well, so we've made one upgrade in the manual calibration in here. We've changed the way the interactivity works. So now you can just click and slide and drag the offset. And then once you place the offset, you can, with another mouse click, you can stretch and squeeze. So the interactivity for this is now following the interactivity for curve normalization in a histogram. It's using the same process in here. Better than that, though, rather than calibrating one plug at a time and then looking at each plug and deciding how well that calibration works plug by plug, you can now look at one view to show all the plugs. And you can you can manually adjust the gains, or you can do an auto calibration, which will find the best fit solution to all the plugs. And if you've got some bad plugs or that just don't fit, you can switch them off and reperform the auto calibration. You can then update the calibration and continue with your workflow. So having all of those per facies and/or zone and being able to do a multi-plug calibration with an error minimization routine, that's really quite a big time saver, and you get a much more robust calibration out of it. We've also added a workflow. Once you've completed that T2 to PC calibration and you run your interpretation, we output a pore size curve, pore size distribution curve. You can now run basically a peak tracker. You can track up to 3 peaks. And oh, sorry, that's not this one. There's a new pore size interpretation log plot, which you can now, it will basically track the peaks. And because you can have up to 3 peaks and there's interactive endpoints for where I'm peak tracking, you can set limits on the pore size. So you can basically use this to track macro, micro, or meso dominant pore size. Let's go back to the PowerPoint. So covered that. Sat height. The main upgrade in here is the Leverett J functions have been extended now with normalized J. This was sort of client request from quite a few clients of ours working in carbonates, particularly in the Middle East. It's become quite a common workflow. There's new cross plots associated with that, so all QC plots are there. Basically, normalized SW is a function of J, and that's fitted this way. And then the irreducible water saturation is a function of either RQI, FZI, Phi, or Perm. And you just select one of those options, and there's 4 coefficients in the regression. This is also the same if it's a Leverett J with a porosity modifier, it's also included. A few other bits and pieces in here. There's a new conformance QC cross plot, which is a cross plot of the entry pressure against permeability. On a log-log scale, you should see a linear trend, so it helps you QC your conformance closure correction. We've added Swanson perm. It's an option now when you're in the setup module. Bring in your PC curves, apply all the corrections, and it will automatically calculate Swanson perm for you. And we've also improved the right mouse click interactivity options on all the QC cross plots. Now you can the remove restore plug or data point is now spread across all of the plots. And finally, this is kind of a small upgrade, but quite significant depending on your work, and in particular in the geomechanics world. It's an upgrade to the copy curves module, that when you copy curves, you can copy curves from one well to another, but previously it's only ever copied in measured depth. You can now copy using TVD to align the depths, or PIX, or both. So where this has got a particular benefit is if you are going to be drilling a new well, so you've got a well plan for your prognosed well, you can take the planned well path deviation survey data, load that into an empty well. So you've got a TVD curve in there, and then you can copy curves from an offset well. Now that might be a vertical pilot hole because you're going to drill a lateral. It might just be, it might be a vertical well that you're planning on drilling. and you can just pick up a nearby well and copy the curves across. And now it will accurately copy them across into the planned well path. So if you're copying in TVD, then it will quite happily work out when you're going back up with overturn sections, repeat sections, things like that. So you get a much better well copy that, in particular, if you want to go ahead and do your wellbore stability planning before actually starting to drill the well. And with that, I will hand you over to Ross.
Thank you, Paul. Let me just take control. Okay, yes, I just wanted to show you a few things we've been working on in the cased hole area of IP. So I'm actually just going to open up the software to do that. So you've already seen the new UI, and as Derek pointed out, there is a cased hole menu area. So now we've got everything to do with cased hole in one area, and we plan on adding more modules to this over time. One update to quite significant update to the production logging module is that we've introduced a workflow for the FSI tool. That's the Schlumberger Flow Scan Imager, I believe that stands for. Some of you may remember that we upgraded the PL module to handle array tool data for highly deviated and horizontal wells before. Initially, we did the maps tool, which is the one commonly used by likes of Baker Hughes, Halliburton, and some others. So we've basically created a new version of that workflow, but for the Schlumberger version of that tool. So you can see here we've actually got sub-modules that are actually handling the depth and ghost tools, which are sensors on this particular tool. So ultimately, we go through the workflow and go into the flow calculation section. The main difference with this tool is that the sensors are placed vertically across the up and down the borehole, as opposed to in a circumferential way that the maps tools were done. So you can actually choose how many segments you want to actually break the borehole up into. 5, or in this case we've got 9. And ultimately we create for each producing zone and every borehole segment, horizontal segment across it, we calculate a velocity, a gas holdup, a water holdup, and then finally a production rate from each zone at each borehole segment. And then they all get added up to a combined production rate, which gets compared to surface rates. And this is just the results in a horizontal plot. So you can see we've got the mini plots on here showing velocity, borehole hold up cross sections. We've got some gas there. And ultimately we calculate the contribution of each zone. And in this case, we can see that most of the oil is coming from this is the heel of the well, and this is the toe. We've got some more oil coming in here. So that was the update to production logging. Probably the bigger news, though, is that we've got a brand new casing inspection module. So if any of you have used the cement evaluation module in IP before, it's kind of loosely based on that similar workflow, but obviously this time, rather than looking at the cement condition behind casing, we're actually looking at the condition of the casing itself. So we can check the casing for general wear or damage or corrosion. So the module can take ultrasonic tools or mechanical multi-finger caliper tools, which this example is a 40-arm caliper. You can quickly take the data in and QC it. We've got a new way of displaying data for this tool. So it's a mesh plot display, and you can actually if I expand that, I can actually spin that data around. So hopefully you're seeing that, so you can see where we've got particular arms that are maybe reading slightly different to the surrounding arms, and where we've got gaps in the data, etc. So it's like a 3D viewer, but it's actually a log track as well. We've then got enter the completion details. We can automatically pick collars, and then we've got interactive data editing. Just open this. We've got this button up in the corner that we can click and drag on areas of data that we don't think is valid. That builds up a list of invalid data, which the module will ultimately remove from the analysis. Once we've cleaned up the data, we then go into corrections, and we've got a variety of the sort of typical corrections you would do to this type of data: automatic despiking, centralization, normalization, drift correction. You'll see if I open up this plot here, you can see the difference between raw data on the left and the processed data on the right. So you can see we had this kind of spiraling on the raw data, which is actually caused by the tool being decentered and the tool moving around as it goes up the well, causing this odd shape. It's not actually real. So we've managed to take that out. We've taken all the bad arms out, the bad sections of data, filled in null values, took spikes out, and ultimately you get a much cleaner data set. That can then be brought in to calculate the condition alongside the nominal values of what the casing should be. And each joint gets an individual grade. You can decide how many grades you want, a minimum of 4 grades. In this case, we've got 8 grades. And we also display the grading as an image as well. So you can see this image with all the different grading colors. And you can actually see in this case that we do actually have a groove in the low side of the well. You can just see it in the middle of the color map there, and there's those grading colors as well for the final grading of each joint. From the table, you can filter which joints you want to see. Here I've filtered down just to the ones that are more damaged than others. From here I can right click on that row where it says we've got 70% wear, and there's the min-max average as a cross section on that joint. That will be where the 70% wear is on that low side. And then finally we can very quickly automatically create a report just as our parameters and casing information used, and then some statistics on the condition of all the joints. It's a pie chart there, and then a table of every joint, the statistics and condition of it. So you can see we can very quickly go from a raw data which isn't in very good condition to a cleaned up processed data set with clear grading. Okay, that was all I had for case tool, so I will hand over to Frans now.
Thank you, Ross. So in the next couple of minutes, I will show what is new in the Geomechanics module of IP 2021. And I have 6 things which I want to mention to you. The first one is that the entire geomechanics workflow is now multi-well, meaning that density estimation, vertical stress, these modules are now multi-well. So there is no need to interrupt the multi-well workflow with all single well windows. So you can analyze several wells at the same time in the same workflow. Second thing I want to mention is this option up here called depth reference options. In here, there are some basic information about the well defined, like Kelly bushing height, water density, but more notably, the true vertical depth curve is defined here, and depth references, which are used to calculate mud gradients, pressure gradients, stress gradients. So it's defined here once and for all, so there's no need to define TVD curves in the subsequent submodules of geomechanics. Of course, they still can be changed along the way, but the idea is to have it defined in one place. Third, I want to mention is this new submodule called Poro and thermoelastic stress. So what this module does is it calculates changes in the in situ stresses, which are a result of changes in the pore pressure and changes in the temperature. For instance, here we have this red solid curve, which depicts an initial pore pressure curve. And there is this dashed curve over here, and there are some reservoir sands here which are slightly depleted. So we have a slightly lower pressure here, a delta P, which affects the in situ stresses, the vertical and the two horizontal stresses. And so this module calculates those effects. And the same is done with different temperatures. Imagine that maybe in the lower two sands here, we want to inject cooler liquids. So this solid green line is a temperature gradient, and the dashed green line is a lower temperature. So there is a delta temperature which affects also the in situ stresses. Now, calculations can be very simple in terms of a single stress path factor which is adopted, but you can also go more complex and account for the different elastic properties of the rocks. Now, next in the list is fractures and fall stress. So this module allows to analyze stresses on fractures. So if you have analyzed in image analysis fractures, and you have identified a number of fractures like here, we see here the tadpoles of fractures with all kinds of directions and dip angles, or maybe you have imported a fracture set. You can now analyze the stresses on these fractures by importing them in the geomechanics module. So here we see the fractures from the image analysis on the left side. Here on the right hand side we see the geomechanics analysis, and we see the same tadpoles here with different colors, green and red. Green meaning that those fractures are not critically stressed, and red meaning that these fractures are critically stressed. And of course, this is important if you are dealing with unconventional reservoirs or tight reservoirs, low permeability. You would like to reactivate your fractures in order to increase the well productivity. So what IP also calculates are these black squares, which are the pressures, the additional injection pressure needed to reactivate a fracture, so to turn this green fracture into a red fracture. Of course, there are some visualization tools as well, which help you to visualize everything. So this is a stereo-net plot of the fractures we see here. So you can see where are the orientations of the critically stressed fractures and where are the non-critically stressed fractures. And there's also a more circle plot available, which again lets you visualize the results. Okay, the fifth thing to mention is an enhancement in the Wellbore stability module. And this enhancement is the inclusion of the planes of weakness. So if you are dealing with weak bedding planes, or maybe transversely isotropic shales, and you want to drill a highly deviated well or horizontal well through such formations, then these planes of weakness, these weak bedding planes, can cause wellbore instability. So there is the option now to include those, and we call that rock strength anisotropy. So beside the conventional isotropic wellbore stability calculations, you can now also include rock strength, anisotropy. So here I want to show you, you can make this kind of plots. The red line here is a UCS strength of a rock, of a formation for isotropic conditions. The blue curve is the UCS as a function of the dip angle of the planes of weakness. So this is the anisotropic rock strength. And just to show you an example of a result of Wellbore stability, we are looking here at the dark green curve, which is the mud weight which the well should be drilled with in order to avoid borehole failure or breakouts, in order to avoid shear failure for isotropic rock conditions. But the light green curve is now including weak bedding planes at a certain angle, with a certain azimuth, and with a certain cohesion and friction angle. And we can see that in the lower parts, the lower formations, we would need a slightly higher mud weight, assuming the anisotropic strength properties compared to the isotropic ones. Okay, and then last but not least is the addition of geomechanics in the Monte Carlo analysis. As Paul has mentioned before, earlier today, all the geomechanics modules have now been added to the Monte Carlo analysis. So there is vertical stress, Poro, thermoelastic stresses, etc. So it's all there. And we're going to look now at an example, a calculation result relevant for geomechanics, where we have varied different rock properties and the pore pressure and the minimum horizontal stress. So we have assumed a certain uncertainty in there, and this is the result. So we call this a probabilistic Wellbore stability plot, and what we are looking at is a probability on the y-axis, the probability of drilling the well without issues is a function of the equivalent mud weight, the mud weight with which we drill with. So the red curve here expresses the uncertainty in pore pressure. The green curves express the uncertainty in borehole failure or breakouts. Black is the uncertainty in the minimum fracture gradient, or the minimum horizontal stress, and the blue curve is the uncertainty in the hydraulic fracture gradient. So we can see that there is a certain mud weight, and if we want to increase the probability of drilling the well without issues, the mud weight which is available narrows down. So this is what I wanted to mention about the new geomechanics developments, and I will hand over for the last section to Tegwyn Perkins, talking about geoengineering.
Right, thank you, Frans. Let me just grab the screen from you and show my screen. It's so technical. Screen 2. Okay, so hopefully you can see my screen now. Thank you, Frans, for those insights into our geomechanics module. I'm going to spend the next few minutes talking about our imaging and associated products. So first of all, Paul's already mentioned the fact that we can now plot a mini plot anywhere in the track. That's going to be a very useful feature going forwards. We've also got the ability to resize it properly now. So if you noticed in these subsequent tracks, it scales to fit the zone we're working in. So that's a nice little feature. A couple of things we've also done, if you look closely at the rows diagrams and the histograms, we've actually got the ability now to color code those based on the data type or the zone that we're working in. Previously, it was just a solid box. One of my favorite features, though, for this going forwards is that we're now able to pick dips without an IA license using the flexible sinusoid. So basically, if you've got an oriented image that's been provided by a service company, you can display it, pick dips immediately on it without IA license, of course. The other thing that you can do here, and as Frans just showed us, is that we can actually use that to pick fractures and import them directly into the critically stressed fractures module. So that's a very nice little feature to have. The new feature for IP 2021 in the image analysis world, though, is we call it Textural Facies Analysis, and it provides the ability to derive facies from image logs. I'll give a demo at the end. I think I'll go through the slides first and then show this at the end. But this particular module is a three-step process. The first thing we do is we take our image log and we transform it using a Fourier transform-like mechanism into the frequency domain. Once we have that image, we then provide a number of statistical tools and filters to the data to come up with a ranked image. From there, we can pass it through into our self-organizing map, where we can basically start classifying it, and then based upon whether we have a calibrated core, for example, we could use that to calculate facies, or we can run it in the uncalibrated mode where we have hierarchical clustering options. And I'll show that shortly. I think I'll get through the slides first. Right, other little features we've added. I'm keeping a track on the time here. We've added an image transform module, which is actually a 3-in-1. The first part of it provides an image calibration. It takes a high resolution image curve. It could be the average value of the entire image, or it could just be one pad that you've given it. And we basically regress it against a calibrated resistivity. So typically an MSFL curve. And you can do this using one of 3 different models. They're all monotonically increasing, which is key. So linear exponential power law. And we can either run it over the entire image, fast but not recommended, or run it zonally or through a user-defined window. And those 2 methods usually come up with a better result. We've included this porosity, image porosity module there as well, because basically it's the same logic being applied, except that we're cross-plotting it with a porosity curve, a neutron density curve, for example, neutron density porosity. The addition to that, and unfortunately it's just off the bottom of this log plot on the right-hand side, we also have the ability to create a frequency histogram of the data at every depth, and use that then to calculate a median porosity value and some porosity percentile curves. We haven't finished this module completely yet because the next step will be to then migrate that and calculate micro, macro, and meso porosities from it. So that bit's part of a work in progress. The final part of this image transform module is basically to enhance the data. Sometimes if you look at this little histogram on the left-hand side, we've got a whole spike of data on the left edge. The trouble is it's all brown. What we're going to see on the image is basically a brown image. By applying this transform, which is essentially just a logarithmic function, we can stretch that data out, tease out more information from the data, and we end up with a nice looking image and oops, gone a bit too far, and just a lot more detail on the image. Other upgrades to IA include this rapid feature count module, which basically provides you with a way of quickly counting features. Now, originally we did it for fractures, but then I think Paul said to me, well, why can't I count breakouts or beds? And we easily just transformed that over to a general picking tool. Very simple to use. We still maintain and keep the picks that you pick, so you don't have to go back and re-pick them again. It's all stored for you in the pick set. Other enhancements that we have made to IA, though, before I get to the one big final one, is a plunge calculation for the breakout axis. It used to be just a constant that we put in there. We're now actually doing the maths and calculating the plunge value based on the borehole orientation. You can also now manually enter a derotation, dip angle, and azimuth. Previously, you would have to take the mean or min or max values from a zone or an area that you've defined. We now let you just type the values in. A couple of other little features in here that we've added. I should point out my favorite is we can finally now render key seats correctly. I believe that was broken for a while, so I'm glad that's back in. Moving on. So this has been a bit of a major work as well, is the interactive net to gross. It's available for both image logs and for curves. And basically you can take an imagegram, run threshold on it, and then you end up with 4 result curves. The first one is basically the first past the post. Which is the predominant facies? Is it yellow or green? Is it sand or shale? And that's what we show here. The second track is an indication of the thickness of each of these beds. So the yellow, the green, back into the yellow again. So that's showing us the thickness of that. The third track is the true volumetric calculation from the image. And the final track is a cumulative calculation from these individual volumes. The same can be done for a curve, and basically we're looking at a thresholding. You just move the red curve left and right, and you can see the image update. And what I'm going to do now, please shout if I've got it wrong, is you should be able to see my IP now. With the new fancy colors, I seem to go with the default. I haven't yet changed it. Right, so the first thing you do with the Textual Facies module is you pick your image, and you can come in here, specify it. We do prefer using flattened images. Image flattening has been part of IP now for 2 or 3 years. Provide it with a regional dip set, flatten the image, and then use it for pretty much everything else. You can also specify it over zones. For every image, we do, and by the way, we do recommend that you run this on high resolution images. So wireline tools, the high resolution resistivity LWD images work fine as well. It'll come up with some options for you based on the data. This is an FMI, so either you can use the entire image, 192 samples per depth, or you can look at individual pads and flaps. By default, we look at the individual pads and flaps, and we give you one of 4 different references to work with. But the default in here, in this case, is a 1-foot tile height. Basically, you run this. I'm not going to run it now because it will take about 30 seconds, which will feel like a lifetime. So I'm just going to go on to the second option, which is once we've done the transform to frequency space, we then have a number of tools for binning and ranking the data. And there's a bunch of options in here for statistics, taking the average or the sum or the maximum, etc. And you can apply filters to the data as well. Again, this actually takes fairly quick time to do this section, but I'm not going to push the button. You've got choices of the number of bins that you might want to look at. And if I just bring up a plot for this, well, there you go. This is the image that we've taken. It's my flattened image. And on the right-hand side, you can see how this ranking has looked. And this blue line represents the cutoff value, which was set to 50. And basically everything from the left edge to the blue line is what we're going to be passing into the self-organizing map. That is on the third tab. And again, this is just our standard self-organizing map that's been modified to handle array data now. We're also taking it at a fairly low reference. We're not going to look for the bigger values. It doesn't take too long, but I'm not going to run it anyway. But once you have that, you then have these 2 options to either calibrate it using one of the clustering methods that we normally use in rock typing or the standard SOM, or to calibrate it to a facies input curve. You toggle which ones you want to work with. In this case, I'm just going to show you the results from running this earlier. And as you can see, the results make a lot of sense. If I zoom into this, you can start seeing, oh, I've got a bed through here in green. This looks very similar to the behavior of this one to the others. So there's a lot of consistency in this, and this was running literally on defaults. I think we can look at adding much more functionality and provide more detail in like a 1-hour demo of this, which would make obviously more sense. The other thing I wanted to show before I run out of time and I get hooked is if I go to image analysis and bring up plot launcher, I need a proper image with dips on it, so I don't need that one. I'm just going to show you the net to gross. In fact, I don't even need dips for that. So bring up an image, very straightforward. I right click and then look at running net to gross. So this is run directly from the image, and obviously we recommend that you use a static image for it. You need a little bit of setup. You've got to specify where you want to write the results to. So my net to gross curve set is the one I want. And I always do this. I always run it on auto update mode and I close that down. So basically what I can do now is looking at my image, I can start adjusting my histogram. This will update in real time. I get my new bed thicknesses, I get my new facies curve, and everything updates as is. There you go. And with that, I'm going to take us back to Ross in mission control.
Thank you very much, Tegwyn. We are right on time. amazingly.
Okay.
So yeah, so as we scheduled, we've got 5 minutes for questions. If you haven't already done so, we'll probably do have time if you want to very quickly type in a question to the questions tab on your GoToWebinar panel. We've already had a couple of questions in. One of them is about the compatibility of IP 2021 on older databases. So the answer is yes, you can bring in databases from older versions of IP and continue to use those wells in the new version of software. However, once you save those wells, you can then no longer go back away to use the older version. So if there's more than one of you using the same database, make sure you all upgrade at the same time.
There is also the tool, there's a tool that you can run on all your databases that will go and search for all the databases and will upgrade them all automatically. It's part of the installer.
Yep.
You hear me?
Yes. Yep.
Okay.
Paul, can you see this other question? Do you want to take one about?
Yeah. Okay.
CSVs.
So yeah, the question is if the output reports, such as the report from cutoff and summation, if that's the same format as older IP versions. It is. We haven't made any changes in there, so you know, all of those standard reports are exactly the same as they always have been.
Yes, it's very much the UI that's changed in the new version of IP, rather than any of the formats of the results or anything. But, okay, we've got another one just come in. How do we use midplot for mineral identification in IP software?
Yeah, I'll answer that one. So there is a standalone plot, but essentially it's kind of an old, obsolete method. Personally, I wouldn't use it. I would use the trimineral plots that are built into the VSW module. So the standalone plots are kind of, if you don't want to use the VSW module, but you still want to do something complicated like involve mineralogy in your porosity water saturation calculations. Frankly, that's exactly what the VSW module has been written to do. So I would just bring my log curves, density neutron sonic, directly into VSW and hopefully a PE as well. And then I can use the multi-mineral option in VSW. That's the way I would do that. It's a better workflow.
However, if you are looking for it, I believe it's under basic log functions. Is that correct?
It is. It's in there as a standalone plot.
Yeah. So calculating basic log functions, you'll find an option there to do that, to make a mid plot.
Okay. I don't see any other questions coming through. If you think of any questions after the webinar, you can contact us. Either if you can you can contact us directly if you're already in touch with any of the experts on the panel, or you can contact us through IP support. So that's ipsupport@lr.org. I think we've actually got another quick one. Is there any plot using log data for discriminating oil, gas, and water accordingly?
Okay, there's a variety of ways of answering that. So in a standard VSW interpretation methodology, if you are using a two porosity method like neutron density porosity, you can make hydrocarbon density the second variable. Now, whether you do that or not, the standard interactive log plot, the color shading that are used for the hydrocarbon is based on whether the hydrocarbon density is more or less than 0.4. So it will automatically shade oil or gas just based on the entered hydrocarbon density. But if you actually wanted to determine it, then you would need to make it a variable, the variable output along with the porosity. So instead of variable row matrix, you could use variable hydrocarbon density. There's other ways of doing that sort of thing, though. There is the standalone gas analysis using mud gas stuff to determine whether it's dry gas, wet gas, condensate, etc. Or also, a similar functionality exists in the formation testing module if you're doing formation gradient analysis using MDT ROT type data. If you've done regressions and fit gradients to the pressures in TVD, there's now the option to, and this was added in IP 2019, there's an option to make a plot from the cross plot. So it will create a track where you will get gradient curves written as text curves. And you can just stick those on any log plot. I mean, it generates a log plot for you, and you can copy paste those tracks and add them to your CPI. So that's where you're determining the hydrocarbon density from gradient analysis and directly bring that into your CPI.
Okay, thanks, Paul. There's one more here, just quickly answer. So it's asking if there's any update to the real-time data stream connector, which would be our Extreme Connect. Not in this particular version, but we've actually got our development team working on an upgrade to that module as we speak. So there should be some significant upgrades, I believe, including the array data that will be coming in the coming months as an update to IP 2021.
Mm-hmm.
Okay, I think we'll just wrap up there then. Yep. Okay.
Thank you,
Well,
everybody.
thanks everyone. Yep, for joining.
Yep, and thank you for your time.
Yep.
Feel free to get in touch with any questions. Okay, bye for now.
Okay, bye.